radius ratio, and just by finding the radius ratio I can find what will be the possible arrangement just by calculating the r plus by r minus, which is a very good thing, because without doing any without going to the lab or doing any microscopic research, I can directly say that the arrangement will be possibly like this. How? We will just come to know in few seconds. For example, if I say coordination number is 3, what does coordination number 3 implies? That the central atom has 3 neighbors. It has 3 neighbors, or it is touching 3 spheres. Now, mostly the case is radius of anion is greater than radius of cation. So I have 3 anions touching each other, and in the space which is provided, what I am doing, I am putting a cation. Okay. So if I say the radius of this cation is r plus, so what I can say, if I draw the triangle like this, if this is r minus, this is r plus, what is this distance? R minus, and what is this angle? 30 degree. Are we clear?
Yes.
So what I can say, see, I am drawing this triangle. So this triangle is this triangle. So I can say r plus r minus cos of 30 equal to r minus. So I can say r plus by r minus equal to 2 by root 3 minus 1, and this comes out to be 0.155. So I can say, and what is this shape? Trigonal linear. So I can say, if I calculate r plus by r minus, if it is coming out to be 0.5155, what conclusion can I make? That the atoms will be somehow arranged like this, and they will be having a coordination number of 3. So just by, see, what we are doing is we are doing the back calculation. Once we know this, we can say that the structure is like this, which is a good thing, because this is an assumption. Are we clear of what we are doing?
Yes, sir.
So just by knowing these values, you know how they are arranged in space. It's a very good thing. Clear?
Yes, sir.
Similarly, if I take, you want to notice now, suppose I have the case like this. I have a coordination number of 4. I have 3 anions. I place a 4th anion on this, and I put a cation in this. So suppose if I want to find the radius ratio in this case, how do I do it? I can say this is r minus, this is r plus, this is r minus. If I say this angle is theta, I can say r minus plus r plus sin theta equal to r minus. And what will this theta be equal to? Because it's in a tetrahedral, so I can say the angle will be 109 degree 28 minutes, and this is half angle, and this is half the angle. So I can say this theta will be, because this is a regular tetrahedral, this angle has to be, yeah, tell me.
Is it above?
No, this is above this. This is not in the same plane.
So tetrahedral that is formed is with the centers of the 4 anions, right?
Yeah, see, this is the center. The vertices of that will be right. And if you take the center of the tetrahedral and join it to the other sides, the angle will be 109 degree. This is the anion. This angle is theta. If you take the center of the tetrahedral, that is where the cation is, na? So if you join it to the other vertices, the angle will be 109 degree 28. So this angle will be theta, and theta will be 109 degree by 2, because you are only taking half the angle. Clear? So I can say r minus plus r plus sine of 109 degree 28 minutes by 2 equal to r minus, and if you solve it, you will get r plus by r minus equal to 0.225. And what is the shape? Tetrahedral. So if you have a radius ratio of 0.225, you can say it will be a tetrahedral shape. See, there is one more case in which the coordination number can be 4. In this case also coordination number is 4. Why? Because this atom is again touching these 4 things. Are we clear?
Yes, sir.
So if I take this is r plus and this is r minus, this is also r minus, so this angle will be 45 degree. Why? Because this is a square. This is a square, sorry. So I can say r minus plus r plus cos 45 equal to r minus, so r minus plus r plus 1 by root 2 equal to r minus. So I can say, so देखो एक बात, what you can see is, even if you have coordination number equal to 4, you have two type of coordination numbers possible. I mean two type of radius ratios possible. What does it imply? See, as the distortions are going to increase, or as the size of the cation are going to increase, it is not going to be stable in the tetrahedral shape, and it is going to expand. And it will still have the coordination number 4, but in this case the radius ratio will be 0.414. So if I want to accommodate a cation of a size bigger than what it was in the case of tetrahedron, then I have to fit it in a square planar shape. What is the shape of this? Okay, what is the coordination number of FCC?
6.
FCC it is 6. So if I take coordination number equal to 6, what does it imply? If I take a coordination number of 6, what does it imply? 4 atoms in the plane, 1 above and 1 below. So the atom which is placed in the center is going to have a coordination number of 6. Now we know that for FCC also the coordination number is 6. So simply what I can say is, and this will be equal to root 2 into A. And what will A be equal to? 2r minus, because the anions are anyways touching each other. So what I can say is, and what is A? I can say again r plus r minus equal to root 2 r minus, or I can say r plus by r minus equal to 0.414. Now this is a strange thing. Even if you have a coordination number of 4, you are having 0.414 in a square planar. Or if you have a coordination number of 6, then also you have the same coordination. What does it imply? See, what does it imply is this. If I am moving from coordination number 4 to coordination number 6, it doesn't happen as such. As the distortions are going to increase, first coordination number 4 will change its shape from tetrahedral to square planar. If the distortions increase further, then it will change its coordination number to 6. That's why even in these two cases you have the same radius ratios, but this structure is more free compared to this, because it's changing its coordination number. So you're getting my point? It's just showing that you're gradually moving from coordination number 4 to 6 via a square planar. So I can say it is like this. Tetrahedral changes to square planar, which changes further to octahedral. Are we clear? Coordination number 6 implies FCC. That's why I'm using this thing. So if I ask you what will be the coordination number in BCC of the central thing, what will it be? 8. So if I want to solve for a coordination number 8, I can simply consider it to be BCC. Coordination number of this will be what? 8. So what I can say? And they are touching along the body diagonal. And I can say A equal to 2r minus. So what I can say? 2 times r plus r minus equal to root 3 into A, or root 3 into 2 times r minus. So this can get cancelled, and I came out that r plus by r minus equal to root 3 minus 1, or 0.732. And what will be the shape in this case? Cubic. Shall I rub this off? See, so what I can say is, if I have a radius ratio starting from 0.155 to the next limit, which is 0.225, I will have a coordination number of 3. As soon as it is 0.225, it will be in coordination number 4. So if it is even less than 0.155, what will be the coordination number? 2. Why? It cannot be arranged. If you want it to be arranged with a coordination number of 3, the minimum radius ratio is 0.155. So if I can say if r plus by r minus is less than 0.155, then it is not even having a coordination number of 3. So the only case possible is having a coordination number of 2. And in that case it will be linear. So see, you have this range. Are we clear? Kya?
Yes.
Yes. Yes.